Students, at last lecture we learned about some basic concept and rules of derivative. Now we are going to start exercise 1.1 from the chapter Differentiation. This is based on derivatives of composite function, and last lecture we learned about what is the meaning of that composite function. In this lecture we are going to start to solve questions from the exercise 1.1. There are total 4 sub questions. From these sub questions, today at this lecture we solve question first and question second only. So here every function is in variable x, and we have to be differentiate that all functions with respect to x. So today's topic is exercise 1.1 questions first and question second. Already we know that there are total 4 sub questions. From these 4 sub questions, today we are going to learn today we are going to solve question first and question second only, which are based on composite function. Question first is differentiate with respect to x. Number 1. The function is x cube minus 2x minus 1 raised to 5. For this one, let the function y is equal to x cube minus 2x minus 1 raised to 5. Here y is a function in variable x, has index 5, and we know that formula for x raised to n, derivative for x raised to n is power always in multiplication of x, and x raised to n minus 1, that is the formula for x raised to n. Here we can consider that whole function as x. It means x raised to 3 minus 2x minus 1 we can be considered as x, and n is equal to 5. So that here the function is in variable x, so differentiate it with respect to x. That is why derivative of y with respect to x is equal to treat that function as x raised to n. Here the power of that whole function is 5. First of all, take the derivative for that index x raised to n as, and that will be indexed in multiplication form. Therefore 5 is in a multiplication form. In bracket, whole function x raised to 3 minus 2x minus 1 raised to 5 minus 1. Index placed by 1, multiply by. This is one of the composite function. That is why we have to be take derivative for the whole function also, and that is derivative of x raised to 3 minus 2x minus 1 raised to 5. We are only derivative for x raised to 3 minus 2x minus 1 we have to be take here. That is equal to 5 in bracket x raised to 3 minus 2x minus 1 raised to 4 multiply by. Here there are 3 terms. We have to be take separate derivative to each one. So the derivative of x raised to 3 is, by using the formula derivative of x raised to n, we can find its derivative, and that become derivative of x raised to 3 is 3 index multiply by x raised to index placed by 1. It means 3 minus 1 is 2 minus, as it is, derivative of 2x. We know that rule, the derivative of any constant term multiply by x. That constant term, whenever we in multiplication of variable, at that time take its constant term, take out of the derivative, it means k as it is. Then derivative of x with respect to x is equal to k multiplied by 1. Its derivative is become only k. It is only constant term. Here also the term constant term is 2 is there. Minus, as it is the derivative of 2x is, by using this rule, as derivative of 2x is 2 minus derivative of any constant term. We already learned that the derivative of constant term is 0. Therefore, derivative of 1 is 0. Next, 5 into x raised to 3 minus 2x minus 1 raised to 4 multiply by in a second bracket 3x square minus 2, and that is the derivative of y with respect to x. It means the derivative of the given function as dy by dx is equal to 5 in bracket x raised to 3 minus 2x minus 1 raised to 4 multiply by 3x square minus 2. That is its final answer. The second example is 2x raised to 3 by 2 minus 3 into x raised to 4 by 3 minus 5 raised to 5 by 2. Let y is equal to 2x raised to 3 by 2 minus 3x raised to 4 by 3 minus 5 raised to 5 by 2 is. Then again here y is equal to whole function raised to 5 by 2, it means whole function raised to index is there. Consider that whole function as x. Then by using a formula x raised to n, we can find its derivative for first form of that derivative is with by using x raised to n. That is, for that one, differentiate with respect to x. Therefore, dy by dx is equal to whole function raised to index is there. Write that index in multiplication form. 5 by 2 in bracket 2x raised to 3 by 2 minus 3x raised to 4 by 3 minus 5 raised to decrease that index by 1. 5 by 2 minus 1, that is 3 by 2. Multiply by, take the derivative for bracket, it means derivative for 2x raised to 3 by 2 minus 3x raised to 4 by 3 minus 5. Therefore, dy by dx is equal to 5 by 2 in bracket 2x raised to 3 by 2 minus 3x raised to 4 by 3 minus 5 raised to 3 divided by 2 multiply by. There are 3 terms in a bracket or in a function. There are 3 terms. Take separate derivative to each one. First of all, take the derivative for 2x raised to 3 by 2. Here 2 is a constant term multiplied to the variable. That is why derivative of 2x raised to 3 by 2, that 2 constant term as it is, multiplied by x raised to n. Here we can use a formula for x raised to n. Derivative for x raised to n has n into x raised to n minus 1. By using this rule, we can find its derivative of x raised to 3 by 2, and that is 3 divided by 2 multiply by index less by 1, that is 3 by 2 minus 1 is 1 divided by 2 minus, again there 3 is in a multiplication of variable, that is 3 as it is, x raised to 4 by 3 is there, again we can use that formula. Therefore 3 multiply by x raised to multiply by that 4 by 3 into x raised to index less by 1, 4 by 3 minus 1, it become 1 by 3 minus the derivative of 5 is, which is the constant term, and its derivative is 0 because variable is upside there, only constant term is present, and we know that the derivative of each constant term is 0, only that constant term is 0. Therefore, here 2 get cancelled, 3 also get cancelled. That is why derivative of y with respect to x is equal to 5 by 2 in bracket 2x raised to 3 by 2 minus 3x raised to 4 by 3 minus 5 raised to 3 by 2 in bracket 3x raised to 1 by 2 minus 4x raised to 1 by 3. That is our final answer. Again, here we can write this answer as dy by dx is equal to, that is necessary, but again by the rule here we have to be write that second one bracket which has index only 1 is there, and next bracket it has index as 3 by 2. By increasing order of index we can write its answer constant multiplication form of that 5 by 2 in bracket 3x raised to 1 by 2 minus 4x raised to 1 by 3 multiply by 2x raised to 3 by 2 minus 3x raised to 4 by 3 minus 5 raised to 3 by 2. That is our final answer. That answer also is sufficient for that one, but we can be right in form of a increasing order of a index also. That is our final answer dy by dx for the derivative of a given example. Then next questions are square root of function is there, and we know that the derivative of root of x we can be considered whole function is equal to x or u also. That is, we know that derivative of root x is 1 divided by 2 root of x. First of all, consider that function y is equal to square root of x square plus 4x minus 7. That whole function is in square root, therefore use the formula for root of x, as the value of x we has been considered as whole function, so its derivative is, for that one, differentiate with respect to x, therefore dy by dx is equal to, by using square root of x, derivative for root x is 1 divided by 2 root x. By using this formula we can write as 1 divided by, derivative of root x is 1 divided by 2 into root of x, but x is considered as whole function. That is why write that whole function in square root form, x square plus 4x minus 7 into, again here we have to be take the derivative of whole function, and that is derivative of x square plus 4x minus 7. 1 divided by 2 into root of x square plus 4x minus 7 multiplied by derivative of this one, and there are 3 terms are present. Taking as a separate derivative to each one, derivative of x square is 2x plus derivative of 4x is only 4 minus the derivative of only constant term present here up. It means x is upside, therefore its derivative is 0. Now 1 divided by 2 into square root of x square plus 4x minus 7 multiplied by, that bracket is 2x plus 4 only. From these two terms we can be take as 2 common, therefore 2 at next step dy by dx is equal to 1 divided by 2 into square root of x square plus 4x minus 7 multiplied by 2 in bracket x plus 2. That 2 is in form of a multiplication of that first one, 2 to get cancel, therefore dy by dx, the final answer dy by dx is equal to x plus 2 divided by square root of x square plus 4x minus 7, and that one be our final answer. To solve this example, we have been used here formula for derivative of root x, because the function is, that whole function is in form of a square root. By using derivative of 1 by that derivative for root x, and it has 1 divided by 2 root x. By using this formula, first step we have solved here. as derivative of root of x square plus 4x minus 7 is 1 divided by 2 into root of x. That whole function is considered as x. That is why square root x square plus 4x minus 7 is there. Multiply by, we have to take the derivative of whole function x square plus 4x minus 7. Then there are 3 terms are present. We know that rules of derivative. Here we have to take the separate derivative for each one. Derivative for x square, derivative of 4x, derivative for a minus 7 also. So derivative for x square is 2x. The derivative for 4x is plus 4 as it is. Derivative for minus 7, here variable is absent, only constant term is present. That is why its derivative is 0. Now at next step, 1 divided by 2 into square root of x square plus 4x minus 7 multiply by 2x plus 4. From these two terms 2 can be get common, that 2 in bracket x plus 2. From numerator and denominator 2 get cancelled. That is why x plus 2 in numerator, in form of a denominator, square root of x square plus 4x minus 7, and that is the derivative for the given function. Now next example is y is equal to square root of x square plus square root of x square plus 1. Here the function is, whole function is in form of a square root. Again, in that function again one square root is also present. That is why here we have to take the derivative for first root, then whole function. Similarly like this one, but here one term is also in form of a square root of 4. Okay, write down this one or take a screenshot. For this example, let y is equal to square root of x square plus square root of x square plus 1. This is the given example. Actually that fourth question is square root of x square plus root of x square plus 1 is. First step is that we have to be considered that whole function is equal to y. Y is equal to square root of x square plus x into square root of x square plus 1. That is the main function, which is in form of a square root. So first of all take the derivative for this square root. Then take the derivative for whole function by rule, or we know that formula for derivative of root x, that function considered as a root x. Derivative of root x is 1 divided by 2 root of x square. So the derivative of this one is, here the variable is x, that is why differentiate with respect to x. Therefore first step is dy by dx is equal to derivative for root x. Function is in form of a root. So take derivative for, first of all take a derivative for this root 1, and that is 1 by 2 root x, and whole function is considered as a x. Therefore its answer is 1 divided by 2 into square root of x. It means x square plus root of x square plus 1. Actually this question is looking as a complicated, but this one so easy. 1 divided by 2 root of x square plus root of x square plus 1 is that we are took the derivative for root x, then derivative for whole main function, and that is x square plus square root of x square plus 1. Next step is that dy by dx is equal to 1 divided by 2 into square root of x square plus root of x square plus 1 multiply by taking a separate derivative to each one. Here we have to be take as derivative for separate derivative for x square plus as it is derivative for x square plus 1. Separate derivative to each term. First derivative is x square and second derivative is in form of again square root. Then dy by dx is equal to 1 divided by 2 into root of x square plus square root of x square plus 1 multiply by. Here again we can use the formula for x raised to n, and we know that the derivative of x raised to n is n multiplied by x raised to n minus 1, that is index in form of a multiplication and index less by 1. So the derivative of x square is 2x, index in form of a multiplication and index which is 2 less by 1, it is only 1, x raised to 1. So the derivative of x square is 2x plus here square root of x is present. Therefore take the derivative for root, and derivative of root x is 1 by 2 root x. By using this rule, 1 divided by 2 root of x, but the value of x is x square plus 1. Value of the function is x square plus 1. That is why 1 divided by 2 into x. It means the function considered function as x, and that function is x square plus 1 multiply by derivative of x square plus 1. So dy by dx is equal to 1 divided by 2 into square root of x square plus root of x square plus 1 multiply by in bracket 2x plus 1 divided by 2 root of x square plus 1 multiply by derivative of again x square. Here we know that we have to be used formula for derivative for x raised to n. Index in form of a multiplication and index less by 1. So the derivative of x raised to 2 is 2x plus derivative of 1 is 0. That is the derivative of x square plus 1, that is 2x plus 0. Now the next step is that dy by dx is equal to 1 divided by 2 into square root of x square plus root of x square plus 1 in bracket 2x plus 1 divided by 2 into root of x square plus 1 multiply by 2x. From numerator and denominator, that 2 get cancelled. Therefore final answer dy by dx is equal to 1 divided by 2 into square root of x square plus root of x square plus 1 in bracket 2x plus 1 divided by root of x square plus 1, and this one be our screenshot. Next question is of 3 by 5 into cube root of 2x square minus 7x minus 5 raised to 5. Here let the function y is equal to 3 divided by 5 into cube root of 2x square minus 7x minus 5 raised to 5 whole function is equal to as a y. But that function here, that root term is used up. Whenever we square root of x, at that time we write as in form of a power or index as x raised to 1 by 2. Whenever we cube root of x, at that time we can be write as x raised to 1 by 3. And here whole term raised to 5, which is in form of cube root, that is cube root of x raised to 5. This one be in form of a whole function raised to 5, which is in cube root, and this can be written as x raised to 5 raised to 1 by 3, which is equal to x raised to 5 by 3. Therefore, first of all, we have to simplify this one as y is equal to 3 divided by 5 cube root. It means in form of an index, whole bracket raised to 1 by 3, 2x raised to 2 minus 7x minus 5 raised to 5, whole bracket raised to 3 is 1 by 3 is there. Because this one be in form of a cube root, we can be write in form of a index as 1 by 3. Index raised to index is there. There will be a multiplication. Therefore, y is equal to 3 divided by 5. 2x raised in bracket 2x raised to 2 minus 7x minus 5 raised to 5 divided by 3. Now that index is a plus. When it comes in a numerator, it becomes minus. Therefore, y is equal to 3 by 5. In numerator, 2x raised to 2 minus 7x minus 5 raised to minus 5 by 3. This is the simplified form of the given example, and now we can differentiate to it. Differentiate with respect to x. dy by dx is equal to 3 by 5 is a constant term. That is why 3 by 5 multiplication form of the given function, which is a constant, take as multiplied form as it is 3 by 5 into derivative for 2x square minus 7x minus 5 raised to minus 5 by 3. Again, the whole function raised to index is there. We have to use a formula for x raised to n. Derivative for x raised to n is n into x raised to n minus 1. By using this formula, we have to be solve that derivative of the given form. Therefore, dy by dx is equal to 3 by 5 as it is, multiply by whole bracket is to index is there. Take index is in form of a multiplication as a minus 5 by 3. Index in form of a multiplication. Index raised to whole bracket raised to index less by 1 whole bracket, and that is 2x square minus 7x minus 5 raised to index should be, here we have to take as less by 1, that is minus 5 by 3 minus 1, that is minus 8 by 3. Using a formula x raised to 1, here we find its derivative as index multiplication form of the whole function, and function its index less by 1. Its index is minus 5 by 3, which is less by 1. It become minus 8 by 3. Into again, here we have to take the derivative for main function, that is derivative for 2x square minus 7x minus 5. That is 3 get cancelled, 5 get cancelled from numerator and denominator. That is why dy by dx is equal to only minus 1 is present here. In bracket 2x square minus 7x minus 5 raised to minus 8 by 3 into derivative of the bracket. There are 3 terms are present. Take again separate derivative for each one. So the derivative of 2x square is 4x minus derivative of 7x is only 7 and the derivative of 5 is 0. Therefore, the answer is dy by dx is equal to minus in bracket 4x minus 7, in second bracket 2x square minus 7x minus 5 raised to minus 8 by 3, and that is the final answer for the given function, derivative of the given function. In question first, there are 6 sub questions. Out of this, 5 has been solved here. Now, question second, we are going to start. That question, in question second, is depend upon derivative for composite function. Now, question second is differentiate with respect to x. First example is cos of x square plus a square. Here also, let y is equal to cos of x square plus a square. Now differentiate with respect to x. There are cos of x square plus a square. Here function of another function is present, that is composite function is present. Therefore, dy by dx is equal to, take the derivative for cos and derivative of cos whole function considered as x. Derivative of cos x is minus of sin x, that is why derivative of cos of whole function is minus of sin x square plus a square into derivative of bracket of derivative of x square plus a square, that is minus of sin x of x square plus a square into derivative of a is a constant term, therefore its derivative is 0. Final answer is minus 2x multiplied by sin of x square plus a square, and that is the derivative of given function with respect to x. The second question is that here also consider y is equal to square root of e raised to 3x plus 2 plus 5. Differentiate it with respect to x, that is why dy by dx is equal to derivative for, first of all take the derivative for root 2x, whole term considered as a x, derivative of root x is 1 by 2 root x, 1 divided by 2 into root of e raised to 3x plus 2 plus 5 into derivative of main function e raised to 3x plus 2 plus 5. So, dy by dx is equal to 1 divided by 2 into root of e raised to 3x plus 2 plus 5 as it is, multiply by derivative for each one. Derivative for e raised to x is e raised to x, therefore derivative of e raised to, but here the x term, it means 3x plus 2 is there. Take the derivative for e raised to x as e raised to 3x plus 2 multiplied by, again take the derivative for that index, it means index is one of the function, that is why we are going to take its derivative of 3x plus 2 plus derivative of 5 is 0. So, dy by dx is equal to 1 divided by 2 into square root of e raised to 3x plus 2 plus 5 into in bracket e raised to 3x plus 2 multiply by derivative of 3x plus 2 is, derivative of 3x is 3 plus derivative of 2 is 0. That is why dy by dx is equal to, in numerator 3 into e raised to 3x plus 2 divided by 2 into square root of e raised to 3x plus 2 plus 5. That is our final answer. So, write it. Third question is log of tan of x by 2. Let y is equal to log of tan of x by 2. Differentiate it with respect to x. Therefore dy by dx is equal to function of function is there. Function of function is there. So take the derivative for first one, derivative for log. The derivative of log x is 1 by x. Therefore here the term x is as tan of x by 2. Therefore the derivative of log of tan x by 2 as by derivative of log x is 1 by x. Here derivative of log of tan of x by 2 we can derive as 1 divided by tan of x by 2. But function of function is there. That is why we have to take the derivative for second one also. That is derivative of tan of x by 2. Therefore dy by dx is equal to 1 by tan x by 2 as it is. Multiply by derivative of tan is, derivative of tan x is tan x sec square of x, that is sec square of the value of x is x by 2 into derivative of x by 2. Again we have to take the derivative of x by 2. Now derivative of here sec square of x by 2 divided by tan of x by 2 multiplied by 1 by 2 is a constant to the variable x or coefficient to the variable x. Therefore its derivative is only 1 by 2. Therefore dy by dx is equal to sec square x by 2. Dy by dx is equal to sec square of x by 2 we can derive as 1 divided by cos square of x by 2 whole divided by 2 into tan x by 2 can be write as sin of x by 2 divided by cos of x by 2. From denominator one of the cos x by 2 get cancelled. Therefore dy by dx is equal to 1 divided by 2 into sin of x by 2 multiplied by cos of x by 2 is given, because from this denominator cos square of x by 2 and denominator is also one of the fraction in which cos of x by 2 is in form of a denominator, one of the cos x by 2 get cancelled. Therefore the answer is 1 divided by cos of x by 2 multiplied by that sin of x by 2, and we know that half angle formula 2 into sin theta by 2 multiplied by cos of theta by 2, it has a formula sin theta, that is sin theta is equal to 2 into sin theta by 2 into cos of theta by 2. Here instead of theta there is x, therefore dy by dx is equal to 1 divided by, it has a formula is sin x. 1 divided by sin x we can be write as cosec x also. Therefore the answer we can be write as cosec x also. For today's lecture we learnt derivative of composite function from exercise 1.1 question first, and from this question second we learned some examples. Its part to be continued at next lecture. It means question second we are taking in a remaining part of that question second we are taking in a second or next lecture.